So we will start at exactly 3. And then this is to inform you that I am recording this para inig na absent karon pwede rin niya ma-review later ang discussion. Okay, but make sure to, yes, Riel, admit.
Excuse me, ma'am. Kaning record ani, ma'am, imo na siyang isend sa G-class na to, ma'am.
Oo.
Okay, ma'am. Thank you, ma'am.
So I hope you will listen class no sa discussion. So dili mo magsalig sa video. Okay, so I will be asking questions from time to time during our discussion time. And then since this is a 1-hour class only, so let us make the most of this hour. Okay, so our second chapter is kinematics. So we'll be talking about motion. So when we say motion, a moving object, nasa mga physical quantities with which we can describe it. Okay? May nag-ask of question. Kadit lang ha, murag na ay magpa-admit. Okay, so katong dili kasulod later class, since dili na kumalantaw na kung kuan na ay magpa-admit kay start na to sa atong lecture class. I-advise lang sila nga magamit og kuan kanang CMU nga account katong institutional email, okay, para makasuludayan sila. Okay. So, kinematics is a branch of physics that deals with motion. So, it enables us to describe motion. What is motion, class? Motion is simply a change in position of an object with respect to time. So, tanang moving object, nag-change na siya of position with respect to time. So, say for example, this tree. Makita ninyo yung cursor? Okay, so this tree here, this fruit here falls off from the tree. So it's we can define an initial position diri sa punuan, and then diri sa ground man yung final position. Okay, so it changes position with respect to time. The same with this runner here, and then kining a train diri this baseball, and then katong airplane. Okay, so these are examples of moving object. Now, we define rectilinear motion. So, on something rectilinear motion, class. So, rectilinear motion is the simplest kind of motion. So, it is the motion of an object along a straight line. So, take note that, it is the simplest kind of motion, and it is one-dimensional by nature. Okay, so rectilinear motion, it is one-dimensional, meaning to say, yung motion kay along lang sa x-axis, or motion along the y-axis only, or motion along the z-axis only. Okay? Now, rectilinear motion can be a component of a more complex motion. So, we can also have two-dimensional or three-dimensional motion. So, we will, as we progress with this discussion, we will encounter or we will describe two-dimensional motions later. Okay, so there are 4 basic quantities of kinematics, and these are displacement, velocity, time, and acceleration. Okay, so displacement, velocity, time, and acceleration. These are the four basic quantities of kinematics. Okay, so let us, before we define these physical quantities, let us start first with the position of an object. Okay, so we can have position in one dimension, so it varies only with x or y or z. Okay, now how do we describe the position of an object? So first is we have to define a starting point, or shall we say origin. Okay, so it is important that we know the origin, or we have to locate the origin. Okay, and then after locating the origin, we can then locate the object relative to the origin. Okay? So, for example, katong kaganina, katong na ay apple nga fruit nga nahulog sa iyaang punuan class. The point of origin is katong kung asa gikan ng apple. So, pwede to siya nato himuon nga origin. Wherein, at that point, dili siya x, no? Motion along the y man to siya nga example. So, at that point, your y is equal to 0. Okay? And then, we will then define motion relative to the origin. So, say for example, motion paubos ato nga point kay negative, motion pataas ato nga point kay positive. Okay, so it is important to have a starting point nga i-consider when we describe motion. Okay, so the direction relative to the origin can be positive. If you are going to the right or upward or eastward or northwards, okay? So you'll have a positive direction, and then negative siya if left gikan sa origin or downwards, okay? And it is dependent on time. So the position of an object is dependent on time. Okay, so the SI unit of position is meters, denoted by letter M. Okay, so here we have, we can call this a reference frame. It is one-dimensional in nature. We can define here motion along the X. Okay, so this is the origin. So for motion that is going to the right, we can define it as the positive direction, and then motion to the left will be negative direction. Okay? So, ingani ka importante ang pag set of origin or starting point when we describe motion, so that we'll be able to know the direction of the motion. Okay, so for example, this particle, the green particle, is moving, or is here, is located here. So now, iyang position with respect to the origin is equal to positive 2.5 meters. Okay, so and then we have this orange dot here. So, yung position with respect to the origin is negative 3 meters because it is nasa sa left sa origin. Okay? So, 3 meters ang iyang kalayon, pero sa left man siya, so you have negative 3 meters. Now, how about this apple fruit, or how about this fruit here? Okay. So in here, we can define any point as the origin class. So diri kay ang yang giset nga origin is the ground, or yeah. So yang giset nga origin is the ground, but pwede pod nga kini siya, no? This would be more preferable nga kung asa ga-start ang motion, dito ang ato ang origin or atong starting point. Okay? So, for example, kini siya nga apple, ang iyaang position after it has reached the ground is -2 meters. Okay? Okay, now that we know how to locate an object with respect to some origin, then we can define the displacement. Okay? So displacement is a change of position over a time interval. So when we say change in position, this means that we have to consider the final position and the initial position of the object. Okay? So it can be written as delta x. Okay? Delta here means change. Okay? So this is actually equal to x final or the final position. So here, we define x as final position. So in most notation, nagagamit po tao sa hay og x sub f. So equivalent ra ni siya ani no x. So x final or x, and then kining x not diri class x sub 0 or x not, this is actually the initial position, or we can also use this notation x sub I. Okay, so we can use x sub f or x for the final position, and we can use x sub I or x not for the initial position. Okay, so f here stands for the final and I stands for initial. Okay, so displacement is a vector quantity. So it has both a magnitude and a direction. And its SI unit is in meters. Now, say for example, you have, we are given with an object that is moving gikan diri class, gikan ani nga point. So can you see this one? Can you see this green dot here? So its initial position is at x sub 1. Iyang gamit is x sub 1, dili x sub I. So this is the initial position equal to positive 2.5 meter. Now, after some time, it moves and then it has made, ang iyang final position is at x sub 2, which is at -2 meters. Gikan there is origin. Okay? So, the displacement, delta x, you can use the front door. Okay. So, iyang displacement, delta x is equal to x final. So, this is the x final class. X final minus x initial. So we will get -4.5 meters. Okay. Now, take note the importance of the origin here. Kung wala ka kabalo nga 2.5 meters ni siya positive, or if you switch signs diri so mali gid ato ang makuha ang answer. Okay? So it is important to know how to locate the object with respect to the origin. Again, so the displacement is -4.5 meters. Now, take note class that this is rectilinear motion. This means, so to, motion along a straight line in one dimension. Pinaka-simple nga form sa sa motion. Pinaka-simple nga form sa motion. But later, we will have two-dimensional motion. And these things, kini siya nga equation class, will get a little bit complicated, but familiar na ang pag-add na to og vector, since displacement is a vector quantity, so we will have vector addition and vector subtraction. Okay, so do you have questions so far?
None, ma'am.
Okay. Let us take a look at the orange dot. Now, at this point, initially, its location is at x equals negative 3 meters. And then it moves, and its final location is at x sub 2, which is equal to positive 1 meter. Now, the question is, what is the displacement of this orange particle or orange dot? So you have delta x is equal to x final. Again, this is our x final. And then our x initial is this one, x sub 1. So you have 1 meter minus negative 3 meters. So that is why you have a positive sign here. And then you have, this is equal to positive 4 meters. Okay? Now take note of the arrow, class. When you move from right to left, you will get a negative displacement. If you move from from here to the right, you will get a positive displacement. Okay, so I hope you have noticed this one. And then we have here another example. We have a runner that is moving from x sub 1, which is 1 meter, and then x sub 2, the final position of the runner after some time is at x equals 7.2 meters. Okay, so the displacement made by the runner is 7.2 meters minus 1 meter. So you have 6.2 meters. Okay? So, dali ra kay pagkuha sa displacement basta one-dimensional nga motion. Motion along the x-axis only. Okay, now let us differentiate distance and displacement. Okay, so how are these physical quantities different from each other? Okay, so take note that distance is a scalar quantity while displacement is a vector quantity. So distance is defined as the total length of path traveled. Okay, so you just need to sum up the length of path that is traveled by a moving object and you will get its distance. While displacement is the shortest path traveled. Okay, so sa kay difference ani class. It is the straight line joining the starting point to the destination. So, for example, we have here an example class. Let us take a look at this example. So, a student is initially at school, and after school, he or she walks 0.5 kilometers to the mall. Wow, doon sa mall iyang school. And then after that, he or she walked 0.4 kilometers to a friend's house. So siguro naghapit siya dire for group study. And then he or she walks another 1.2 kilometers to the market para mag-dinner. And then after that, after going to the market, 0.3 kilometers padulong na sa iyang balay. Okay. Now, let us get the distance and the displacement. So, ang distance daw, class, is the total length of path traveled. So, meaning to say, i-add up lang ni nato ning tanang iyaang lakaw. Okay? So, na kay 0.5 kilometers plus 0.4 kilometers plus 1.2 kilometers plus 0.3 kilometers. And you will get the total length nga gi-travel sa student. So that is the distance. So the distance traveled by the student going home from school is 2.4 kilometers. Okay, you can check it with your calculator and then you will get 2.4 kilometers. But ang iyaang displacement, you just have to consider the initial position or the initial location of the student and the final location of the student. So, ang iyang initial location is ang school. So, diri. Ang iyang final location is the house. So the displacement made by the student is the shortest path traveled. So it is the straight line joining the initial position and the final position. Okay? So in this case, it is 1 kilometer. Nakuha ninyo ang difference, class?
Yes, ma'am.
But this is only the magnitude of the displacement. You need to specify a direction. Yes? Next question? Okay, you need to specify the direction by siguro pwede ka magbutang og katong angle with respect to the horizontal, the positive horizontal, or the positive x-axis. Okay? So we will get into that later. How about speed and velocity? So how are these two physical quantities different from each other? So speed is a scalar quantity and velocity is a vector quantity. Now, speed is, or specifically, the average speed is equal to the total distance traveled divided by the total time it took for the travel. Okay, or we can call that the time interval. So total distance, distance denoted by d, divided by the time interval delta t. Okay, or it is a scalar quantity and it has units equal to meters per second. While velocity is defined as displacement over the time interval. Okay? So, kung si speed, total distance over time interval, velocity is displacement over time interval. So, velocity is a vector quantity and since displacement can be expressed as x final minus x initial, then pwede siya na ito i-sulat dito sa numerator divided by the time interval, delta t means t final minus t initial. Okay? So that is for the velocity. Velocity is actually defined as the rate at which an object changes position with respect to time. We can have the average velocity, which is equal to this one. So this is actually the average velocity. Average speed, and then we have the average velocity. We also have instantaneous speed and instantaneous velocity. So when we say instantaneous, that means at that very small time interval. So gamay kaayo ang time interval. Mura siya at that particular instant or kana lang gyud nga time at that moment. Okay? So velocity or kung manyan kag instantaneous speed, that means speed at a specific instant of time or specific point along the path. Or kung manyan po kag instantaneous velocity, that is velocity at a specific instant of time or specific point along the path. Okay? So that is the definition of instant. It refers to a single value of time. It has no duration at all. So we cannot say that it is a time interval. Kaya wala man siya duration. Okay? So marag kana lang gid nga particular moment. By the way, kanang ginabasa sa speedometer sa mga sakyanan ni class mo na siya ang instantaneous speed. Okay? So now, how is this different from the average speed and the average velocity? So, average velocity tells the velocity of the path for the whole duration. So, kung si instantaneous velocity kay walay duration, si average velocity kay naa siya duration nga ginalantaw. Na siya ginatanaw nga time interval. Okay? So, say for example, kung mayon kag average, tanawon nimo ang ang change in position within this hour. So, dako man siya nga time interval. So, pwede siya natatawagon as average velocity. Okay? Nakuha ninyo ang difference, class? So, this is an example of a speedometer. ang speedometer kaya ang iyang gina-measure is the instantaneous speed. Okay, now, here are rules in determining the sign for velocity. So, we have to take note of this. If the final is greater than the initial, if the final position is greater than the initial, then the object is moving in the positive direction. Okay? So if the final position is greater than the initial position, then the object is moving in the positive direction. So the sign of the velocity is of course positive. And then if the final position is lesser compared to the initial position, then the object is moving in the negative direction. The sign of the velocity is negative. Okay, so masayon siya class kung inyong tanawon ang displacement. If the object is moving to the murag masayon siya, if the object is moving to the right, then it has a positive velocity. It has a positive displacement, so it also has a positive velocity. Now, if the object is moving to the left, it has a negative displacement and it also has a negative velocity. Okay, so kana lang inyong timan-an. How about acceleration? So acceleration is another physical quantity that we can use to describe motion. So it is a vector quantity and it is defined as the rate at which the velocity changes during time interval. Okay, so if the velocity of the motion is changing with respect to time, then that means your object is accelerating. Okay? So, ga-accelerate daay ng object kung mag-change ang iyang velocity with respect to time. Okay, so we can define the average acceleration as V final minus V initial divided by delta t, which is the time interval. Okay, so you have change in velocity divided by change in time. So that is acceleration. Okay, so there are three situations in which an object is accelerating. So, kano sa man mag-accelerate ang isa ka object class? So, kano sa mag-accelerate ang isa ka object? You can type in your answers here in the messages, in call messages.
If naka-experience siya force, ma'am.
Yeah, that's right. But that's really the reason why an object accelerates. Okay. So, kung maka-experience siya og force, ito na siya, no? But what are the three situations in which an object is accelerating, considering only the velocity, not the...
To-change yung position, ma'am.
Okay, so if the object is changing position with respect to time, so that is not a guarantee, class. It is not actually a guarantee that the object is accelerating. So for example, bisag mag-move ang isa ka object, pero kung constant ang iyang velocity, then that means it is not accelerating. Zero iyang acceleration, ano ha? Kung mag-move siya at constant speed. Okay? So, the first case is when the magnitude of the velocity is changing. Bisag ang direction is constant. So, for example, rectilinear motion, meaning to say, nag-move siya in a straight line. So, meaning to say, wala siya nag-change of direction, no? Nag-move lang siya padulong sa east. Okay. If the magnitude of your velocity is changing, bisag wala siya nag-change of direction, then it is accelerating. Okay? So, kung mag-speed up siya, mag-slow down, that means nag-accelerate na siya. Okay? Now, another case is when the magnitude of the velocity is constant, pero nag-change yung direction. So, kung dili siya rectilinear motion. Like, for example, constant iya ang speed, constant iyang velocity, pero nagliko-liko siya or nag-agi siya curve nga path. Okay? Or agi siya hump or ingana. So, if the velocity's magnitude is constant, pero nag-change iyang direction, then, meaning to say, i-accelerate ang imoang object, ana. Okay? And of course, kung both ang magnitude ang direction sa imo ang velocity kay nag-change. So these are the three situations in which there is acceleration in a moving object. Okay. Na picture out ninyo, class.
Yes, ma'am.
Okay, I hope so. Now, here are important rules in determining the sign for acceleration. So kaganina, murag sayo na kayo no ang pag determine sa sign sa displacement o sa velocity. Kung padulong sa left or paubos, negative. Ay, sorry. Left ay paubos, negative. Kung padulong sa right or upward, positive. Now, for acceleration, we need to consider the initial and final velocities as well as the motion. Now, for example, we have here a police car that is initially hinay ang iyang daga, no? Tapos nagkakusog siya. Meaning to say, it is speeding up. Okay. So we have here two police cars. Ang isa, kini siya class kay nagsugod siya nga hinay, tapos, nagsugod siya nga hinay, makita niyo yung cursor na, tapos nagkapaspas siya. Meaning to say, it is speeding up. Nagkapaspas. Speeding up. And then, it is going to the right. So, both of these police cars are going to the right. But this one is speeding up. And then, the second one is slowing down. Okay? So, if the motion of the object speeds up and it is going to the right, then yung acceleration is positive. Again, if an object is speeding up to the positive direction, so pwede, dili lang siya limited sa right, no? Pwede po siya upward, padulong sa north. So, that means the acceleration of that object is positive. Pero, kung padulong siya sa north or padulong siya sa right, padulong siya sa east or padulong siya sa north, tapos nag-slow down, ang acceleration niya kay negative. Okay, nakuha ninyo ang difference, class?
Yes, ma'am.
Yes, ma'am.
Okay, I hope so. And then, how about if you have objects that are moving in the negative direction? So, kung may tag objects moving in the negative direction, that means to the left or downwards. So, nakay duha ka objects diri nga nag-move to the left. Tama atong object. Nawala atong object diri, class. Nawala ang motor, ang nag-move kay kanisya. Okay. So, if an object is slowing down to the left or downwards, then the sign of acceleration is negative. Okay? So again, okay. So balik ko na ko ha. If the motion is speeding up to the left or downwards, the sign of acceleration is negative. But if it is slowing down to the left or downwards, then ang iyang acceleration is positive. So like this delivery driver here. So hinay siya, slowing down, padulong sa left. So ang iyang acceleration is positive. So again, atong balikon ha, Naay duha ka cases wherein positive ang acceleration. First is if it is moving in the positive direction and is speeding up. And then the second case is when it is moving in the negative direction but is slowing down. So these are two cases wherein positive atong acceleration. And then we also have two cases wherein negative ang acceleration. So the first one is if it is moving to the positive direction but is slowing down. And then the second case is when it is moving to the negative direction but is speeding up. Okay?
Okay, ma'am.
Okay, ma'am.
Now we have motion with constant acceleration. So how do we say that, how do you describe a motion that undergoes constant acceleration? Okay, first, unsa kano sa zero ang acceleration gani sa imong object class nga nag-move?
Instant siya, ma'am.
Kung constant ang
Velocity.
velocity. Okay, so kung constant ang velocity, that means zero ang acceleration. Okay. Now, unsa po ni meaning kaya ning constant acceleration?
Speed up, then hunong din, ma'am.
Constant ang acceleration. Okay. So, when we say constant ang acceleration class, that means the velocity changes at a constant rate per unit time. Okay, so we will have one specific example later of motion with constant acceleration, which is free fall. Okay, so for now, we will get to know this four kinematics equation. So the four kinematics equations can be used only for motions that undergo constant acceleration. Okay, so here is equation 1. V sub x equals v naught x plus a sub xt. So v sub x here is the final velocity. V naught x here is the initial velocity. And then you have here the acceleration along the x times time t. Okay, now kining mga subscripts diri nga x class, this denotes motion along the x. So kung motion along the y ni siya, we can replace this with y pod. So mga subscripts lang ni siya. Okay, and then equation 2 is this one. You have x, the final position equals x naught, which is the initial position, plus v naught xt plus 1/2 a sub xt squared. Okay, so this is the second equation. And then for the third equation, we have another equation for the displacement. So you have x equals x naught plus 1/2 multiplied by v naught x plus v sub x times time. Okay, and then we have the fourth one, the last one. We have v sub x squared minus v naught x squared equals 2 a sub x multiplied by x minus x naught. Okay. So again, these are the four kinematics equations, and we can use these equations to describe motion with constant acceleration. Pero kung ang imo ang acceleration kay mag-vary, dili siya constant, dili ni siya nato pwede magamit ng mga equations class. Okay? So, take note of this, that for a uniform or constant acceleration, the instantaneous accelerations are equal to the average acceleration. Okay? So we have problem number 1. So let us use the four kinematics equations in solving problems involving motion. Okay, so here is the first problem. A man walks 25 meters due north. He turns and continues walking 30 meters due east. Okay, so calculate the distance traveled and the displacement of the man from its starting point. Okay, so let us analyze this problem class. So first, natural motion along the Y. So 25 meters due north. And then he turns and continues walking 30 meters due east. Okay. And then we are asked to calculate the distance traveled and the displacement of the man from its starting point. Okay, so let us start with i-draw na to, no? So from the origin, for example, this is the origin, the red one, the red point. The man walks 25 meters due north. So this is 25 meters. And then he turns and continues walking 30 meters due east. So pa east, pa right. Okay. So 30 meters. Now, the distance traveled by this man is just the total length of path taken by the man. So you can just add 25 meters plus 30 meters. Okay, so it does not matter kung asa siya nga direction ni adto, basta distance ang ato ang kuhaon, distance. Dili mag-matter ang direction. So distance equals 25 meters plus 30 meters, which is equal to, pila man siya plus 55 meters. Now, for the displacement, this is a little bit different with what we had sa ganito. Ang atong solve ka ganina kay rectilinear motion na to, no, sa example ka ganina. But this time we have a two-dimensional motion. So we know that the definition of the displacement is the shortest path traveled by the man. Okay, so this is the displacement. Displacement is a vector quantity, so we can add an arrowhead. Okay, so how do we solve for the displacement? Any idea, class?
Unsa galito, ma'am? Can you repeat?
How do we solve for the displacement since this is a two-dimensional motion? Di ba natay displacement is equal to x final minus x initial, but we cannot use x final and x initial here because we have y. We also have motion along the y, which is this one. So this is motion along the y. This is
Pythagorean
motion.
theorem, ma'am.
Okay, very good. So we will use the Pythagorean theorem to get the magnitude of the displacement. So you have the square root of, asa gani ang x ani? 30 meters, no? 30 squared plus 25 squared. Okay? So this is the magnitude of the displacement, and then its direction can be obtained using tangent inverse. So you have tangent inverse of your y, which is 25, and then your x, which is 30. Okay, so I hope you have your calculator there with you so that you can help me with the calculation. So this one is
39.80, ma'am.
okay, so it's 39.80 meters. So kini siya, ang iyang length day ani class kay 39.80 meters. Tapos ang iyang direction, so let us define a horizontal axis here. And then we can get its direction, theta. So you have tangent inverse of 25 over 30 is equal to
39.80, ma'am.
39.80 gihapon. The same with
0.9, ma'am.
ito to,
2.9.
2.9 degrees. I-check daw kung naka-degrees na siya or radians mode inyong calculator.
39.80, ma'am. And
Okay. Tapos ang theta is 39.80 gihapon.
ang sa displacement, ma'am, kay 39.05 tong sa displacement, ma'am.
This one. 39.05 ni siya. This one is 39.80.
Yes,
Degree?
ma'am.
Yes, ma'am. 81.
81. Okay. So, 0.5. All
Yes,
right.
ma'am.
So, we can write the displacement. Okay. So, therefore, distance walked by the man is 55 meters. College fee, ang kasko kay nandito sa pinakakilid. Ay, dito sa DLL. Yeah, next room. Sorry, class. Okay, so therefore, distance is 55 meters and then the displacement made by the man is 39.05 meters, 39.81 degrees counterclockwise from the positive x-axis. Okay, so we have obtained the distance and the displacement. Can we proceed to problem number 2? Napatay time. Yes, napatay time, class. Okay. Do you have questions? Pero no? Clear siya makalibog pa. Okay. A group of 5 students decided to have an educational tour in the industrial plants of the city. A group of 5 students decided to have an educational tour in the industrial plants of the city. The tour guide begins to drive at 8 a.m. and stops at 4 p.m. Okay. Within this period, the car covers 260 kilometers. And, okay, so we are given with the initial time and the final time. We also are given with the total length of path traveled. So this is the distance. And then this one, 180 kilometers due north of its starting point. So we are given with the displacement. Displacement ni siya, class. Kaya na may direction. Okay, so find the speed and the average velocity for the day. So this will be easy. So the first thing that we should do is to solve for the time interval. So solution is to solve for the total time, delta t. So since, di ba ang oras ng class no, kay dili siya pareha sa anang numbers nga, dali ra na to ma-minus, like for example, kini, dili ni siya na to 4 p.m. minus 8 a.m. We cannot do that. So, ato gid siyang pintahon kung pila siya ka oras. So, yan na lang nato, no? We have from 8 a.m. na kay pila ka oras until 4 p.m. 9, 10, 11, 12, 1, 2, 3, 4, 8 hours. I think it's 8 hours lang. Sakto ba? So, 8, 9,
Yes, ma'am.
dili pilang 8 ha, o count. 9, 10, 9, 10, 11, 12, 1, 2, 3, 4. Okay, so careful ha. So, 8 hours lang. So, delta T is 8 hours. Now, we are asked to find the average speed and the average velocity for the day. So, this will be very easy lang. Okay, we are given with the distance and the displacement. So, average speed is equal to distance divided by time interval. So, you have 260 kilometers divided by 8 hours. So this is equivalent to pila man siya?
32.5, ma'am.
32.5.
32.5 kilometers per hour. Kilometers per hour or kph ni siya. Usahay class kay gina sulat ni nila as kph, kilometers per hour. Kilometers per hour. Okay, how about the average velocity, V average? So you have 100 displacement. Displacement divided by the time interval. So 180 kilometers. So kini lang sang magnitude akong ibutang class tapos ato lang din butang direction later. 180 kilometers divided by 8 hours.
22.5, ma'am.
Okay, so the average velocity is 22.5 kilometers.
22.5, ma'am.
22.5. Okay, 22.5 kilometers per hour. Tapos ang iyang direction is the same as the direction of the displacement, which is due north. Due north from the starting point. Okay? So do you have questions?
None, ma'am.
Wala pa no so far. So let's proceed to problem number 3. Murag na patay time class. A bicycle accelerates to a velocity of 0.5 meters per second in 5 seconds. The average acceleration over this time interval is 0.5 meters per second squared. Okay, so what was the initial velocity of the bike? So we are asked to find the initial velocity of the bike. Okay, so we are given with the time. This one. And then this one is velocity, final velocity, which is 0.5 meters per second. And then we are given with the constant acceleration, which is equal to 0.5 meters per second squared. So what was the initial velocity of the bike? Now, this problem involves velocity, acceleration, and time. Okay? So we can use the first equation of the 4 kinematics equations. So recall equation 1, which is V sub x equals V naught x plus A sub x t. Sakto ba nga equation, class? Yes.
Yes, ma'am.
So V sub x equals V naught x plus A sub x times time. Now we are given with the initial velocity, we are given with the final velocity. Mani siya no, atong final velocity. And then our initial velocity is what we are looking for. So initial velocity is unknown. And then we are given also with A sub x and then t. So given V sub x equals 0.5 meters per second, A sub x equals 0.5 meters per second squared, and then time equals 5 seconds. Okay, so we can get this one by manipulating our equation. So we can just, we have to isolate this, kaya mo siya ang target variable. So you have V naught x equals, ibalhin ni siya na ko sa PCAS class para ma-isolate ni siya. Eh, di ba muna itong target variable? Isolating this one, we have V naught x equals V sub x minus. Since gibalhin man ni siya na ko sa PCAS nga side, no? So mahimo siyang minus A sub x times time. So we have 0.5 meters per second minus A sub x is 0.5 meters per second squared multiplied by the time, which is 5 seconds. Okay, so make sure that the units are consistent. So na kay meters per second diri, meters per second squared multiplied by second, so you will get also meters per second. Okay, which is the unit of velocity. So this one, negative point, negative 2. So it's negative 2 meters per second. So the initial velocity is negative 2 meters per second. V naught x. Meaning to say, sa negative direction dahil siya. 2 meters per second to the west. So, pwede niyo siya ninyo isulat as 2 meters per second west. Okay, so I guess wala na tayo time for another napatay 5 minutes class. Let us take this time to look at problem number 4. Okay. So a car speedometer reads 35 kilometers per hour at one instant. Running along the same direction, so the same direction na wala ta nag-change yung direction. After 25 seconds, it reads 40 kilometers per hour. So calculate the magnitude of the average acceleration of the car. Okay, so we are given actually with the final velocity and the initial velocity. So this is the final velocity, V sub F. Kini siya. This is V sub F. And then 35 kilometers per hour is our V sub I, the initial. Okay, and then we are given with a time interval. So instead nga giingnan tag gikan alas 8 taman alas 4, ang giingon sa ato kay kato ng total time nga nag-travel ang car. So it's 25 seconds. So this is the total time, or we can call this the time interval. Okay, calculate the magnitude of the average acceleration of the car. So average acceleration, A average, is just equal to V final minus V initial over the time interval T, or pwede na ito butang T final minus T initial or delta T, or T lang, kay hatag naman si 25 seconds. Now, notice nga wala na to gi-consider ang direction because it is said nga nag-move naman daw sila along the same direction. Okay, so it is rectilinear motion. Basta rectilinear motion, ma-simplify gid atong calculation class. Okay? So, you have 40 kilometers per hour minus 35 kilometers per hour divided by 25 kilometers per hour. Seconds. Now, we need to convert units because our time is not consistent, no? Dili consistent ato ang pag-express sa time. So, natay hour diri, naputay seconds diri. Okay, so we need to convert this first. So, pwede na to i-convert ang 25 seconds to hour. So, saan ganyan siya pag-convert? Convert 25 seconds to hour. So, 25 seconds multiplied by 1 hour equals, pila na siya ka seconds class? 2,600 seconds. Okay, so you have 25 over 3,600. Please help me with this.
6.94, ma'am.
6.94 times 10 to the minus
3, ma'am.
minus 3. Okay. So it is very small. It is a very small
0.3.
time. So we have 5 kilometers per hour divided by 6.94 times 10 to the minus 3. Ay, ganun 4 ni class. This is 5. Ilan man ni siya?
4 ra gyapon siya, ma'am, kay 4 ang 4.
40
ma'am.
minus 35 is 5 kilometers per hour.
5.
Okay. So 5 divided by 6.94 times 10 to the minus 3.
720.46, ma'am.
720.46. The unit is hour man siya, no? Kilometer per hour squared. Okay? Pwede na siya na to i-convert full class to meters per second squared, but I guess we do not have time for that. So, okay. So since the standard unit of acceleration is meters per second squared, we can convert this to meters per second squared. Anyway, wala mo po niya i-specify kung unsa nga unit dapat ang imo ang makuha ang average acceleration. So, check ra gyapon ni siya. Okay? So, we will continue with our discussion on...
Excuse me, ma'am.
Yes?
Ay, kanang, kuhaan mong question, di ba, 5? Ay, di alam, wala din, ma'am.
Permission to ask, ma'am.
Yes, yes.
Ma'am,
Go ahead.
anong need na to i-convert ang seconds into hour?
Yes, because we need to be consistent with our units. Diba naman kay kilometers per hour. So, dapat kay ma-convert ni nato og hour or kung kuan, dapat kay diretso na kini siya may atong i-convert og meters per second. Kini siya dili na to i-convert. Okay, so we have to be consistent with our units. So, you have to take note of this nga pag naamoy mga isolve nga mga problems nga lahi-lahi og units, like for example, ang isa kay kilometer, ang isa kay meter, you cannot operate directly. You have to convert units first for you to be consistent. Okay?
Okay, ma'am. Thank you.
Yes, another question from Juliana. Juliana is raising her hand.
Ma'am,
Ha?
madungog ko, ma'am.
Yes, yes.
Kanang atong Monday, ma'am, ba kay wala na ako na-submit tong problems bitaw, ma'am. Kay na-late magud ko tapos wala na ako na-submit ang ako, Pwede na ako to ma-submit next meeting.
You have to submit it as soon as possible.
Okay, ma'am. Thank you.
Okay, any other questions with regards to the topic?
None, ma'am.
Okay,
Wala, ma'am.
None
I'll
so far, ma'am.
see you again. I'll see you again next meeting. Online lang gyapon ta class para paspas atong discussion. Okay. Mas paspas man gud siya kay kana dili na ta magsulat ba, di na ta magsulat erase, sulat erase. So